Our next speaker, we'll make a switch here, is Dr. Shahar Somin. She's a faculty member at Ilan University and head of the Network Intelligence and Coordination Lab. Shahar, please.
Hello, everyone. Thank you, Irad, for the introduction. Happy to be here. Today, I'll be sharing with you our latest research revolving how we can detect influence when no links are actually visible between the coordinating entities. And this is what we call ghost networks. Okay, so a bit of motivation before we dive into the details. When we look at the physical world, the real world around us, people are coordinating, they are talking to each other, they attend conferences, right? They listen to talks. And even if we look at these groups of coordinating individuals, I've plotted here in red, they have connections with one another, right? But when we look at the online world, well, this world is full with so many different platforms, right? We have social media platforms, we have phone calls, we have banking, blockchain, darknet, you name it. And apart from this variety in platforms, the data is extremely fragmented. So now, if we look at this coordinating group of people, they might be acting on different platforms, right? So these connections that we know that exist in the real world, suddenly they disappear. We don't have access to these links. And the question is, this is the challenge, how can we actually detect coordination, real world coordination, when the network is hidden? Okay. So we will base our work on the fact that people don't act at a steady pace, right? There isn't any 1 minute time interval between any of our activities, right? Alternatively, we act in bursts. A person will have a burst of activities, then a period of silence, then another burst of activities, and a longer period of silence. And what we've shown in our recent paper published in Nature Communications is that this pattern of burstiness, it actually forms an individual signature of the person, right? So if we have two different individuals, each one will have this different temporal signature. And even more interestingly, we show that if we have two people coordinating in the real world, we'll be able to see that their patterns in the online world, despite acting on two different platforms, they will be quite similar. They will be aligned, right? Even if these people act in different timings, okay? And now I want to prove my point using 3 case studies. The first one is cross-platform identity matching. We have a single individual in the physical world, and this individual has multiple profiles, right? He has his Twitter profile, his Facebook profile, you name it. And the goal will be to match, to link these profiles back to the real-world individual, to understand that they belong to the same real-world person. And what we see in this work is that the bursty model, the model that is based on these temporal signatures marked here in red, is able to outperform a variety of baseline models. Specifically, it is able to outperform structure-based models. These structure-based models, they rely on the fact that our neighborhood, the number of friends that we have on one platform and the number of friends that they have on this platform will be similar to the neighborhood that we have on another platform. But we see that in terms of identity matching performance, this is not the case. The performance of these structure-based models is quite poor. And similarly, when we compare to temporal models, these are foundation deep learning models, right? State of the art. They are still performing worse than this simple model based on this bursty signature. This takes us to the second case study, community detection within a single platform. So now we are expanding the challenge. We don't look at a single individual. We look at a group of people. They are coordinating in the real world. And we relax our online demand in the sense that we assume for now that they all act on a single online platform. But they might not have direct links to one another. Maybe they're hiding their coordination. Maybe we don't have access to the entire data set. Show me a person that can actually analyze the entire Twitter, right, at hand. So in that sense, we might not have all observable connections between them. Nevertheless, we see that the bursty model, once again, is able to outperform both structural and temporal state-of-the-art models into experimental settings, both on social media platforms and on financial markets. This takes us to the third case study, the hardest of them all. We have a coordinating group in the real world, in the physical world, and now we allow these people, these are actual people, to act on different online platforms. So, of course, we won't see all of these connections, right? They won't be visible to us. And once again, on two experimental settings, social media and financial markets, we see that we are able to outperform them. I also want to show you a bit about the robustness of this methodology of looking at the burstiness of people. And specifically here, we see that even after a year long, right, we haven't been active for a year, we'll still be able to detect 35% of the individuals, right? Another issue of robustness is the robustness to data fragmentation. And specifically, if we don't have the entire data set, right, this could happen. Or if people try to hide their coordination, well, we see that the performance declines. This makes sense, but it is still much higher than the baselines that we've seen before, even though the fact that these baselines, they have the entire data set at hand. This takes us to the last thing that I want to share with you today, and it is how we can use this burstiness-based model to detect influence campaigns, right? This is a work that has been made in a collaboration with Professor Irad Ben-Gal and Tal Buchnik from Tel Aviv University. And we are looking at an influence campaign on Twitter, specific a Cuban one. And first of all, we try to detect this influence campaign using content-based models. So the green points here are the benign profiles, real humans. They have nothing to do with the coordination, with the influence campaign. And the red ones are the actual influence campaign tagged by Twitter. And what we see is that content-based detection doesn't work in this case, right? Because they're all talking about similar things. We cannot separate the two groups. However, when we use the burstiness-based detection, we see that we are able to separate them into two different communities. There will be diving into the details of this work this Thursday by Tal Buchnik at AI Week, and you are more than welcome to come and listen. I want to thank you for that, and for more details, you can scan this barcode. It will take you to our Nature Communication paper. Thank you.